Well, good morning, student, and welcome to our first class, our first week. And of course, DAA, Design Analysis Algorithm, with the course code IF1630033. Let me introduce myself to you. My name is Gusti, Agung, Gede, Arya, Kadyanan. I'm a lecturer here in Technique Informatics in the University. We usually offer this course in all semester. In this week, we try to set it out, to configure it out with no course. We will focus. Our first focus is to discuss about course rundown with about one semester, and effectively at about just 4 months actually. Let's see. And about administration, I will accompany you as a lecturer this class at about 1 semester, and we introduce my room and my office in this building, building in the first floor. And also feel free to contact or discuss by using emails. You can look at the whiteboard by email ID. With the credit value, this course we await about 3 credit value, and also our class will start on Thursday about 8 until 9:30. We also have prepared our course material. Let's see, learning management system, with the course ID 740. Yes, then we try to look at our main course material using a textbook here. We are using the book entitled Introduction to Algorithm. You can also using first, second, and third, of course. MIT, Presmego Hills, and Thomas Terminal Esterson. About book, and we also can using another book as supporting course material like Java programming or any others to support in the programming language. Okay. In this week, we will discuss about what the topic about objective and also a prerequisite and grading scheme about this course. Let's see. You can look at the objective. We can learn here and we can master the technique. This is our target here for objective. Let's see here. We learn and master, and for the target, for objective target here, we need to know after the completion about this topic, you can also already know, you can improve your knowledge about technique for analysis, how to analyze it, how to design, and also giving the proof, about an algorithm, on a basic algorithm. Focusing on correctness and efficiency of algorithm, of course. But we need to know this course, and of course with really heavy mathematics. So the prerequisite course. I mean, we need to already know about the discrete math 2, discrete math 1, discrete math 2. Overall about the discrete math, where we know how to count. The objective is why we study about discrete math, because we need to already know everything and all around us. We need to count. We need to compute them. So before we compute and another material not including in numeric, we also need a discrete math to convert to doing the conversion about one representation of data into what we call it with a group of numbers, so we can do it a computational logic as well. And then we also need the data structure and the algorithm. We need a data structure because we're purely using pseudocode. We are using a flowchart to give a good representation of our algorithm here. After that, we will discuss about the grading scheme. We set out these grading schemes in several sections when doing the assessment. We gather many assessment value with a different percentage. Especially, you can look at the whiteboard here. We're using midterm exam. After we discuss several topics, we will doing a sort of test with we call it a midterm exam with weight about percentage about 20% for the midterm exam, and then for a final exam as well, we also using 20%. And for interaction, in class interaction or assessment, including assignment and for quiz, we are spread it by 2 and 30% assignment for worksheet on the homework. You can doing this for, by yourself, or also you can discuss in a group or work in a pair, of course, depending on the situation in every week. We can give you the information in every week when I give you an assignment. And then 30% for a quiz. We're using an online quiz by using technology and learning management system, which I have so many question bank. I will give you some questions and give you many rules on it, and the system will counting how you're graded. Sometimes we're using every grade, something we're using a highest grade, and also we can roll it accidentally in every week's course. And here we go. We are now going to a course plan. Yeah. In every week, as I told you, we send out every week have different topics, except our first week. So the first week with the no lectures, we just discuss about how to configure out our course, this course, how to configure out discuss how to configure out our interaction, lecturing, and many other things, including in a general topic. That's the first week. And the second one, second week, we will discuss about what is algorithm and what algorithm method, and how can people say algorithm as. Okay, let us hear our course plan. I have to configure it out every topic in every week. With the first week, we don't have any lectures. We don't do any course in the first week because we need to discuss. I need to inform all our students about the rundown, about the course rundown, and then we need to also explain about the grading scheme, about the objective, prerequisite, and many other things, what we need to schools to do in one semester. Let me see about in the second week we will discuss both algorithm and algorithm as a technology. As we know, most applications running including an algorithm, but nobody care about the correctness or efficiency in algorithm itself. We will discuss about how important algorithm is and how algorithm will work in every application efficiently. And then continue to the third week. We will introduce the insertion sort methodology.
insertion sort is a methodology that we are usually using when we are flying card. We rearrange card from small into high number, or we are doing ascending, sorting from A to blah blah blah. We using insertion sort, using invariant, looking invariant, and also we are running time analysis. We check the running time analysis in every algorithm. Also, we will calculate the growth of function. Because we using a formal method, we need to know about the growth of function, even they are linear or quadratic and so on. And also we will also discuss about asymptotic notation, which overall we will using mathematical notation. And then the fourth week we will discuss about the word chart. With this implement defect and conquer. We spread most problem into a small part. We will divide into a small part, and so using this method to solve them one by one from the small part and then another part until the problem is complete, get the solution. In 8th week, we also discuss about the quick solve, randomized algorithm, and probabilistic analysis. And a week 6th week, we have heap data structures. What we have maybe in a senior or junior high school, we will discuss about heap, ED5, then a heap sort. We will be using heap to sort in all we have data, numbers data. To get to check also a lower bound of sorting by comparison. Yeah. Let's see week 7th week, we're doing a sorting in linear time. So we are done. We are doing some cases, and also we will calculate on our statistic in general flexion problem. Yeah, and midterm exam. This is midterm. We want our assessment. We will get the value from it. We percentage about 20%. And we 10th week we study about the red black tree, dynamic order statistic, interval tree, basic data structure, and so on. We are using the red black tree to spread it into the binary tree to solve the problem, of course. And dynamic programming also, when someone wants to doing optimization. Yeah. So you can also use the metric chain. We call it metric chain multiplication, and then memorization down the subsequent. Yeah. When you want to doing more grading algorithm, also we study here about activity scheduling, knapsack problem, and in certain cases. Also we use a graph for reachability, for the minimum spanning tree also, and also source span, maximum flow, and NP completeness. Using NP completeness here, non-deterministic probability completeness. Until now, no one solved these cases. Of course, connected to the NP completeness, we will discuss about Hamiltonian cycle, circuit satisfiability, and NP completeness proof also. Yeah. Then the last we will doing an assessment with the final exam. Let me see for a general rules. Of course, we have a rule here, and of course we are about late. Yeah, as a lecturer, as a student, maybe don't try to come late because you will get the punish when you come late. You can enter the class if you're late. So and then we also using percentage 75% to represent this role will enroll you to when you join the midterm exam, of course. And we here when you work homework or assignment, we will not be accepted if you send or submitting the homework late. And also no remedial for some people who not attending the midterm exam. It show yeah. When you answer your homework, you can also doing a conversion. Of course, this is where we forbidden for you to doing any cheat method. And this is you can see overall the role, the class role. Then you can also grade this on the learning management system, of course. And if you have any difficulty, you can discuss with us. You can discuss with your friend, you can discuss with me, and feel free to contact me by email, by phone, or also on a social network like WhatsApp, Facebook, and many other social networks. And then I think that's all we can explain, we can describe about the role and class configuration. So you can ask us whenever you want, if you still don't understand once our topic, once our objective here in our class. And so far, have you any questions so far? If yes, please raise up your hand. No? Okay. I think this course enough for today. And thank you very much for your attention. Hopefully we will see you next week in a good condition, of course. Thank you very much and good morning.